Hello there. I am Bruno Kapular, and I will be talking about the testing of model verifiers within software development in the automotive industry. Okay. So I will give you a short introduction into the topic, and then I will talk about how we tested the System Definition Verifier, also known as the SDV, and I will comment a little bit about the results of the testing. So these days, vehicles are better, faster, and safer than ever before, mostly due to advanced driver assistance systems. However, they are also more complex than ever before, and that makes automation a very big part of creating automobiles these days. This, of course, includes the automatic verification of AUTOSAR models, which are a big part of system models in the automotive industry. But these automatic verification tools also need to be tested, and the SDV, which we tested as part of this presentation, was one of those tools. So a little bit about tool qualification. So tool qualification is the process of verifying such tools. So the first step in tool qualification is, of course, to verify whether the tool even needs to be qualified. This process is defined in the ISO 26262 standard. It usually has 3 steps, which are analyzing tool impact, its error detection, and the necessary confidence level. The qualification methods are also defined in ISO 26262. There are 4 different methods defined. They include increased confidence from use, evaluation of the tool development process, tool validation, and development in accordance with a safety standard. The one we decided on for this paper or presentation was tool validation, which includes creating a test suite to test possible interactions. So what is the SDV? So this SDV, or System Definition Verifier, is a tool for automatic verification of AUTOSAR models. It compares these models to to requirements defined in its system definition guide. It is important to note that the tool itself is not yet finished, and the version we used for testing was version 096. So how did we create this test suite? We created the models we used for the test suite using DaVinci Developer. We made 44 models, and they all contained 1 or more faults that or errors that needed to be detected by the tool. Each model was made to test a different requirement defined in the SDG, or its system definition guide. We compared the errors it did detect to the one we expected it to detect, and then we made a table like this. This is, of course, only a part of the table we created. As you can see, it only has about 10 or so. We gave all the models names and descriptions, and then we created some statistics from the table. However, the tool itself is in a very unfinished state, so we had to create our own user interface to make everything a bit easier. It was a very simple interface, as you can see, with some added functionality over the tool itself. We made we added a function that allowed us to verify multiple models sequentially instead of having to select them one by one. So what are the results of our testing? So the version 096 checked 107 requirements defined in the system definition guide. The models we created were supposed to test 73 of those, so not all of them. There was the 73 requirements meant that we could get 73 possible different errors with different error IDs in the during our tests. Now, as you can see, we did not manage to detect all of them. Two were left undetected, and the overall number of errors detected was actually a lot higher than the models were designed. This is probably, actually, we verified that this is due to overlap between the models, with some errors appearing twice or even 3 times. But it is all expected, so we did not find any issues with this. The issues we did find were that there was a few unhandled exceptions, as expected from a program in such an early state, but present nonetheless. Of course, a very glaring issue is the fact that not all requirements are checked by the tool. So we cannot reach any concrete conclusions at this state. The models we created were also only for testing the tool itself. This means that not all they are not very good at presenting the tool's performance in the context it's meant to be used, which is to be used on finished large AUTOSAR models that represent entire systems. And also due to the fact that the models we made were made for a very early version of the tool, this means they may become obsolete for future testing as changes are made. So how do we fix some of these solutions, some of these problems? Well, we could change how we make the models in the future to make them more reusable. For example, basing them, making them in such a way that they conform to most of the requirements defined in the SDG. For now, we made them only to conform to the current 107 requirements, meaning that any future requirements that are added to be verified, they will not conform to them, and we will get more errors on these same models. So we could also upgrade these existing models to account for this. However, this would be a very long and annoying process. Testing on real in-use models will be necessary in the future, of course, to verify the tool in context that it is meant to be used. And one useful thing that we think will be necessary to add to the tool is to enable verification only of the requirements that the user wants to check. This would also make any models we create unobsoletable, if that's a word, because we could only test for consistency between different software versions. So in summary, 97% of the errors were in the dedicated test suite were detected. The tool itself does its job well, but not perfectly. It does have issues. It is incomplete, and similar testing will be necessary in the future, but it is a promising start for the tool. And that is it.